yesterday we talked about distance, but we just talked about distance when we have some kind of line and we have numbers on it like this. And we talked about how far is it from this point to this point. And we figured out that it was the absolute value of x2 minus x1. Pretty basic. Today we're going to talk about distance in a coordinate plane. So that's what this picture is. You have an x direction and you have a y direction, and all of your points have an x value and they have a y value. So this point right here might be 1 comma 2, and this point here might be 6 comma 4, or any combination of numbers really. But so when you look at this picture, you see that we have a point and it has an x value and a y value, and then we have another point Q that also has an x value and a y value, and these little ones and twos let us know that this x value is different than this x value, and this y value is different than this y value. So don't get too hung up on these little ones and twos and thinking that they're making the problem more complicated. They're just there to indicate that this value is different than this value. So if a point P has the coordinates x1 and y1, that just means it has coordinates. And there's another point Q, and it also has coordinates, and this should say x2 and y2. Then the distance from P to Q, so from P to Q, if we want to know how long this is, can be found using the distance formula. And the distance formula says that D, obviously stands for distance, equals the square root of x2 minus x1 squared plus y2 minus y1 also squared. And so I know it looks complicated. If you've never seen it before, you may be ready to just turn the computer off and be done with math for today. But stay with me a little bit longer. It's not that difficult, and once you get used to it and you know what to do with it, it's real easy. Remember, the distance from P to Q is the same as the length of the segment. So if you see this in a problem, it wants to ask how long is PQ? How long is it? What's the length? It's going to be written like this. It's going to say PQ equals. And all you've got to do is figure out what the points are for P, figure out what the points are for Q, and write whatever they are, x2 minus x1. When we do these problems, we're not going to be putting x2s and x1s. We're going to be putting whatever these numbers are, plus y2 minus y1 squared. And I'm sure this still seems complicated, but let's just jump right into it, okay? Practice is the best way to get good at this. Find the distance between points C and D and round to the nearest tenth. So if we look at a graph here, we have an x-axis, we have a y-axis, we have a C and a D. So they want us to figure out how long is this segment. Well, the distance formula is going to tell us that information. So if we remember, it's D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Then all we need to do is take these numbers and plug them into this formula. So my first point here, C, that'll be this one. So I'll say that this is x1 and this is y1, because this point has an x value and a y value. Then I come over to D, x2 and y2. Then all I'm going to do is go back over to my formula, and I'm going to write D equals the square root of x2, which is 5, minus x1, which is negative 4, squared, plus y2, which is 1, minus y1, which is negative 6. The only way to get this down is just to practice it, and I promise you will get better at it if you're just willing to try. Now we're going to take everything under this radical. If y'all remember, this is called a radical. Some people call it a square root symbol. And we are going to combine it all and squeeze it together and make this very simple problem very quickly. So we keep on writing d equals the square root. Now, inside this radical here, 5 minus negative 4, two negatives make a positive. So that's really 5 plus 4, which is 9, plus 1 minus negative 6. Well, another negative makes it positive. So 1 plus 6 is 7 squared. And then we're just going to finish it up. 9 squared is 81. Plus 7 squared, 49. So the square root of 81 plus 49 is the square root of 130. Now we look up here and it says round to the nearest tenth. So we need to use our calculator and figure out that d equals the square root of 130. The square root of 130 is approximately equal to, this is from the calculator, 11.4. So for our problem here, our final answer, we would write CD, so the distance from C to D, equals 11.4. Remember, the key to this is just recognizing our x1 and our y1 and our x2 and our y2. We just need to find those values and put them in the formula. So we got one more to try. If you want to pause it, give it a try yourself, go ahead and do that. I'm going to go ahead and work it out, but if you want to practice, the best thing to do would be pause it right now, work it out, and then see what happens. So this is x1 and y1, x2 and y2. So we start with our distance formula. Square root of x2 minus x1 squared plus y2 minus y1 squared. Something that people ask me a lot of times when they're learning math is, Mr. Lewis, how do you remember all those formulas? The way I remember them is I write them down every single time that I use them. And that way, when I really need one of them, I've written it down so many times that I know it. And that's what you're going to have to do. You need to write it every time you do it. Don't get lazy or you will pay the price for it when you have to do this on a test. So x2 minus x1 squared plus y2 minus y1 squared. So 9 minus 2 is 7 plus 4 minus 5 is negative 1. And what you have to be careful about is make sure that you keep track of your pluses and your minuses. Use parentheses to keep things organized. So the square root of 49 plus negative 1 squared is negative 1 times negative 1, which is positive 1. Again, I'm out of room. I move up here. D equals the square root of 50. I go up to the instructions to say round to the nearest tenth, so I punch square root of 50 in the calculator. This symbol right here stands for approximately, so that lets me know I rounded it. I'm not exactly right, but I'm close. I get 7.07. So we don't know the letters for these points. This problem we knew C and D. Here we don't know the letters, so we're just going to say D equals 7.07. And actually, I shouldn't say D equals. I should say D is approximately. And that's that. Have a good evening.